LAURELIN, a research project funded by the European Union and supported by the Japan Science and Technology Agency, JST, aims at developing innovative solutions to improve green methanol production from CO2 hydrogenation in terms of energy efficiency and production cost. The project's main objective is to introduce a new generation of catalyst systems, perfectly adapted to advanced reaction processes, including microwave, magnetic induction, and non-thermal plasma. During the project, conventional heating serves as benchmark against the three defined catalysts. As the project is in its final stage, the LAURELIN Consortium presents this video whose objective is to present the main developments and advancements found during the past years of EU and Japan-funded research. LAURELIN Project Coordinator Luis Iranzo Martinez outlines the importance of the project for the further decarbonization of transport and energy-intensive industries. What is the benefit of LAURELIN's research for green methanol production?
Global warming is a hot topic in the research programs of the European Union. It has been demonstrated that more than 60% of the contribution to the global warming from greenhouse gases comes from CO2. This is a problem that science wants to take with different technologies as are the carbon capture and storage, but also the utilization of this carbon capture. In this sense, LAURELIN is going to work in the use of this carbon capture with green hydrogen to produce renewable methanol. Methanol is one of the more efficient fuel to decarbonize the transport sector.
Throughout the project, the nexus between European research institutions and Japanese partners have been fruitful since the very start. For 4 years, 6 partners from the EU, 2 from the United Kingdom, and 2 from Japan, ranging from research organizations, higher education institutions, and SMEs, have been intensively working together to create new synergies between Europe and Japan. The combined work is paying off as the project saw its intermediate culmination during the first EU-Japan cluster event in Tokyo held in November 2023. LAURELIN argues that cooperation between both blocs has a huge benefit for research. This project is an excellent example of this and shows that the EU-Japan nexus works and delivers. What are the main positive outcomes that have resulted from this collaboration?
Participating in international collaborations is a real enriching experience, especially considering how to address global environmental problems. In this sense, having project members with different expertise and from different countries really help to find solutions to problems from different approaches. In particular, in the LAURELIN project, we have had the opportunity to work with researchers who are experts in unconventional catalytic systems, and this has allowed us not only to use our metal-containing zeolites as catalyst, but also we have already learned a lot about this new type of reactors. And finally, I would like to highlight that the network created has established the base for future collaborative projects and also student exchanges.
Apart from delivering key scientific output for the decarbonization of our transport and energy-intensive industries, LAURELIN also aims at developing the next generation of scientists and other stakeholders in the field of catalyst research. We asked our young consortium members why this is important and what the benefits will be of their efforts in this field. How did the LAURELIN project affect your research or academic development?
The LAURELIN project has significantly expanded my research capabilities, allowing me to transfer my skills from the food industry, which I focused on during my PhD, to the field of carbon capture and utilization. This project also gave me the chance to collaborate with experts from diverse fields, which saw the big change from the isolated nature of my PhD work. I gained valuable insight into how large-scale projects are managed and developed. It also helped to improve my communication and teamwork skills, which are crucial for both academic and professional growth.
What will the LAURELIN project evoke for the next generation of researchers?
The LAURELIN project will inspire the next generation of researchers to explore innovative and sustainable technologies to improve green methanol production from CO2 conversions. I believe by fostering the cutting-edge solutions, it will promote the environmental research and policy development. Future researchers will be motivated to push the boundaries of the research and build up the new findings to address climate change problems.
What are the main key takeaways the project has for young researchers in the field of catalysts?
The LAURELIN project also highlights the importance of developing efficient and sustainable catalysts for CO2 conversions. It can encourage young researchers to focus on eco-friendly and scalable solutions for catalyst development. Also, the project highlights the crucial roles of the collaborations between different partners in the field of catalysis. I think it will encourage the young researchers to build more networkings or collaboration opportunities to achieve the breakthroughs.
Another impact LAURELIN is aiming for is delivering an advanced characterization of data based upon our research on catalysts. We asked our project partner, University College of London, UCL, what this means and how their work further nourishes the project and other scientific developments. What is advanced characterization, and how does this help LAURELIN's quest of developing a new generation of catalysts?
The design and implementation of new catalyst systems requires a thorough exploration of their structure and behaviour. Our research group at UCL, based at the Research Complex at Harwell in the UK, specialises in catalysis and materials chemistry, focusing on catalytic reactions under in situ and operando conditions. We study the behaviour of catalysts provided by our partners, utilising a range of spectroscopic and scattering methods with both national and international research facilities. Our experiments aim to clarify the correlation between catalytic activity and structure for different families of catalysts for use in different novel reactor technologies. We aim to identify the active species and explore different reaction pathways. This work enables our partners in LAURELIN to develop more efficient catalysts which are less susceptible to deactivation, striking the balance between activity and stability. The data generated from these studies also serves as a foundation for investigating new materials for future research.
What elements of your work can be used for further investigation, and how are the data of LAURELIN helping in this?
As young researchers, participating in the LAURELIN project has given us the opportunity to collaborate with international leaders in catalyst synthesis and development, to conduct experiments in world-class scientific facilities, and to be part of pioneering research that not only tackles one of the greatest challenges of our time, CO2 emissions, but also seeks to build a more sustainable future.
LAURELIN has been important not only in creating a new generation of catalyst systems, but also in helping the next generation of researchers grow.
Through the strong bond between all project partners, LAURELIN was able to make some great scientific breakthroughs during the past years. These can play a major role under the LAURELIN research, but also in many other applications. Adolfo Benedito Borras, LAURELIN Technical Coordinator, explains this scientific advancement on catalysts and how this can nourish further research.
Welcome to AIM+ facilities. In detail, this is a laboratory of synthesis of AIM+, where we are developing different processes related to polymers and other products. In LAURELIN project, we are working on the synthesis of renewable methanol from the conversion of CO2 and hydrogen. And for this reason, we are working on different innovative reactors like non-thermal plasma reactor, like the induction reactor, and finally the microwave reactor. In this case, I would like to show you the microwave reactor that we have here, where we are producing the methanol from this conversion of the CO2 and hydrogen. Here we have the waveguide where the microwave are produced, and in this line we obtain all the products, and all the products are analyzed in this gas chromatograph.
What scientific breakthrough has the LAURELIN project discovered?
The most important thing that we have observed in these years of the project is that all these reactors has a very high energetical efficiency. The heating is very well controlled, and from an energetical point of view, the consumption is very low compared with the traditional heating processes.
How can this help in other applications?
In this project, we are working only with the obtention of the renewable methanol, but all the things that we are working in this project can be used in the future to develop and to obtain other very interesting chemical fine products, like, for example, methanol, in this case, ethanol, ammonia, and DMA, for example, among others.
This project has received funding from the European Union's Horizon 2020 Research and Innovation Programme and is supported by the Japan Science and Technology Agency, JST, under the SICORP programme. Find out more on laurelin.eu.